Viruses don't recognize borders. They don't need passports. They're constantly moving. Everywhere we go, they go. As a scientific community, we have the tools to prevent another deadly pandemic. But if we're not proactive, we will relive history.
I've been an immunologist at Rush University Medical Center for 40 years. What I saw at the beginning of the pandemic in 2020 was something I've never seen before in my life.
Rush and the Abbott Pandemic Defense Coalition have the shared goal of preventing the next pandemic by looking at a diverse source of samples and signals in the environment. Gives us an early indicator of threats that is not showing up in the clinic yet.
If we have Rush right here, we can move out and look at wastewater, and then we can look at the rat populations. As we begin to survey in this area, we can see where are the intersections between the patient populations we have at Rush and then wastewater and the rat samplings. How could we do more with the rat populations in this area?
So we're gonna head out to about 4 neighborhoods in Chicago, grab some tissue samples from those rats, and then go ahead and send them on to Stefan's lab.
If we look at what's circulating in the animal populations, we can see what the risks are for spillover events into the human population.
All right, this area looks good. So I'm gonna put this trap in here because we've got a lot of rat burrows in here. There's a lot of cover. People in cities typically have more contact with the environment and the animals in it. We're looking at those relationships and how that might be related to disease transmission. So to make sure we have fresh samples, we check our traps every day, first thing in the morning, and the tissues are sent to Rush for analysis for RSV, COVID, and monkeypox. We were surveying to see really what's out there, and we can hopefully get ahead of those kinds of diseases so we can see what folks are being exposed to before it ends up going to people.
Our lab will be receiving the specimens. Then we can do very targeted approaches. We're looking for a known pathogen and we want to see if it's there. Or we can do a non-targeted approach where we say, let's just sequence everything because we know about some pathogens, but we don't know about all of them.
And then wastewater, Rachel, how does that work then?
Similarly, so we picked 7 sewer sites around the city to represent different populations. How can you tell you've hit it?
Visual.
Yeah. Wastewater shows what passes through people, things that people are infected with, things that are on people's skin. Anything that gets washed down the drain ends up in the wastewater itself. Can you believe that 50 mil sample that you took represents a whole community? So we can report these samples that we'll bring back to the lab. We report the data directly to the public health department, and we can see what the trends are, if things are going up or down. If we find something, we can alert the public health departments at least within 48 hours.
One of the advantages of having the sequencing core here at Rush is our ability to turn these things around much more quickly. But it's not just about getting the data rapidly. It's about integrating data from multiple sources across not just the city itself, but also globally. That's so crucially important. So we need more data from more locations, faster, and for better integration of multiple sites across the globe.
So all this data will pull together for the Abbott Pandemic Defense Coalition to help us move forward and move this into our partner sites. So I think everything we learn here today will really be applicable across the globe.
What we're doing could really be a model for surveillance in a North American, highly resourced urban setting. By having the Abbott Pandemic Defense Coalition networked around the world with other hubs, we create a protective net that is helping prevent the next pandemic.
I saw with my own eyes what happened here at Rush in 2020, and I want to be sure that that never happens again.